Welcome to this DesignBuilder webinar, where I hope to show you how much easier and hopefully more productive your modelling life could be using DesignBuilder, especially if you're currently grappling with using a tool that you find complex, time-consuming, or even unstable. I'm Dave Cocking, and with me today is Andy Tyndale, and Andy will be helping me to answer your questions at the end. As this webinar is predominantly for those using other tools, I'm going to spend a few minutes at the start with an overview of DesignBuilder's capabilities. After that, I'll move on to the live demonstration, and during that, I'm going to show DesignBuilder's fast modelling workflow up to and including the baseline building and HVAC generation, and that's going to be my main focus today. I'll then talk about some of the wider capabilities in DesignBuilder, including daylighting and CFD, and I'll show you how these can be run from the model that we developed for our ASHRAE baseline generation. I also want to show you why it's no longer necessary to start a project using a simpler architectural tool and then ditch that model and start again once you move into detailed modelling. You can quickly set up your early stage model in DesignBuilder and develop it as your project evolves. Using one software to cover your modelling from the early stage through to detailed design and also into certification could save your firm lots of money. You can submit questions at any point during the webinar via the questions box in the control panel, and we've allocated time at the end to answer as many questions as we can. The webinar is being recorded, so you can access that later if required. So for those new to DesignBuilder, what is it? We like to think of it as a fully integrated simulation toolbox that you can use to run all of the analysis types that you see here from one single core model. DesignBuilder is all about productivity. The concept is actually remarkably simple. It's a GUI, a graphic user interface, that is fast to learn and enables you to quickly create models, run simulations, and generate outputs using the best open source engines available. One model, many uses. That means you can generate additional revenue streams for very little extra modeling work. I'll show you this in a live demo, but before I do that, I'll give you an overview of the different elements that you see here. So looking briefly at each of those elements, we can import models in GBXML format from all standard industry BIM tools or via the Revit plugin. Or you can quickly create your own geometry with our user-friendly geometry tools. Many of our customers don't have access to BIM models and find it faster to create their geometry within DesignBuilder, which is far easier than in comparable energy modeling tools. Many energy modelers I speak to have actually become disillusioned by the hype around BIM, and their experience is very often that BIM models are badly created and they often don't import well into simulation tools, and that's regardless of the tool that they use. So they spend a lot of time trying to fix the imported model. They feel frustrated that the geometry is really the modeling aspect that they have the least influence over, but they seem to spend a disproportionate amount of their modeling time either trying to fix issues with imported BIM models that were badly created, or with trying to edit geometry in software with perhaps less capable geometry tools that make it time consuming. As well as with all modeling software, DesignBuilder can't miraculously fix a badly created BIM model, but we do provide you with the tools to either quickly create your own geometry or to easily edit existing geometry or geometry that you've imported. There are tools in DesignBuilder that make QA checking much faster. You can visualize color rendered data and results on external surfaces, as you can see here, and also on internal surfaces. For example, visualizing cooling loads across all zones on a floor plan. This grid edit tool makes it easy to see and change all the model data in a grid format. You can also export the model data in CSV format, import your own tabulated data, and re-import the CSV file to update your model. In DesignBuilder, you have all of the normal EnergyPlus outputs for energy and comfort performance, and also for QA checking HVAC operation, like temperature and flow rates at individual coils at each time step. EnergyPlus enables you to generate and output results at sub-hourly intervals. That's important for QA checking the performance of fast-acting systems like HVAC and natural ventilation openings at both design conditions and at different conditions throughout the year. This really can be helpful to diagnose any input issues and give you the confidence that your model is working as you expect before you start running full annual simulations. You can create EnergyPlus detailed HVAC systems much easier and faster in DesignBuilder. All of those node connections in EnergyPlus are taken care of behind the scenes. There are an extensive range of templates available to select and edit, or to build your own system from components available in DesignBuilder's library. You can also quickly run sizing calculations to determine loads and emitter sizes using the ASHRAE location data. There are lots of easy methods for applying a range of shaded devices, from simple window blinds, overhangs, louvers, through custom shaped shades and sails. Also a variety of rendering and visualization tools to aid understanding and communication with your team. You can also analyze and report for global certification schemes, including LEED, BREEAM, and Energy Star. And DesignBuilder includes tools that automate the ASHRAE 90.1 baseline building and HVAC system creation. And then you can generate a completed LEED V4 minimum energy performance calculator spreadsheet. So just to remind you, here's what I'm aiming to cover during the software demonstration. I'm going to break with the slides right now and go into the software, spend a little time in there building up the ASHRAE 90.1 baseline model, and show other tools and build up the HVAC system, and then I'll move back to the slides. At that point, I'll start to talk a little bit about daylighting and CFD, and show how I can use the fully integrated daylighting and CFD tools to assess the model that we just developed. The reason I'm doing it like this is that I want to show you a workflow that we don't believe is possible in the same amount of time using other energy modeling tools. So we think it's really important that you can see DesignBuilder in action rather than just hearing us talk about it. The modeling I'm going to do today and to show you could probably be done in 10 or 15 minutes, but there's not really much point in me just rattling through a process without explaining what I'm doing. This webinar is all about giving you an opportunity to see whether DesignBuilder could be useful for you. So I've decided to extend the live demo a little to show and explain a few more important points in a little more detail. I also thought it would be much more realistic if I run some simulations live during the demo so that you can see the results. Clearly, I've only got limited time to cover a few of DesignBuilder's inputs and options, but there will be time at the end to ask any questions you might have, or you can email us with any questions. So here goes. Okay, into the DesignBuilder interface. Before I start to create my own geometry, I'll just point out this context sensitive help in the panel on the right hand side here. This is really useful, and it provides options that are relevant to what you're actually doing in the model at that particular time. So you can see this is a fresh model, so I've got options here that are relevant to creating a new building. I can import 2D drawing file, so 2D CAD plans, facade drawings in a range of different formats, including PDF and DXF, or I can import from using this import BIM model, import a GBXML file, or from our Revit plugin. So I'm now going to show you how you can quickly create and edit geometry freehand in DesignBuilder, really just to give you a sense of capability. There are lots of free resources available, including online tutorials and past webinars to show you the geometry creation tools. So I'm just going to pick a selection today. So I'll start by drawing a rectangular block, and I'll set the rectangular option there, and I'll just draw this 100 feet by 100 feet, and that will create automatically a 12-foot high block. I'll recenter that. I'll now use this add surface tool to basically take a rectangular chunk out of this southern facade. I know it's the southern facade because here is the north arrow. So I'll just put my cursor on here, and I'll take out a 30-foot wide section, and let's make that 50 feet deep. I could have drawn this really easy using the geometry creation tools, but I thought it would be a little different just to do it the way I've done it. The next step, I'm going to add a roof on top of this block. So again, if I go back to my add new block tool, this time I'm going to use the polygon perimeter shape, and I'm just going to draw a monopitch roof option here, and then just manually drag that back until I pick up this snap point on that north facade, and that lines the new block up with the existing block. I'll select that now and mirror that block. So I'm going to create a mirror image of it, and I'm going to reflect that in this green y-axis here, and pick up this little green snap point, drag it over to the other side, and snap it on top of my east block. So I'll just recenter that. So what we've got here is perhaps this is the first iteration of the whole modeling process. It might be the first model, early stage beyond massing, and inevitably the geometry will change, either the geometry that you've created or geometry you've imported, it doesn't matter. So we can use DesignBuilder's geometry tools to change the geometry after it's been created, not a problem. So what I'm going to do now is just drag or edit a whole surface. So I can use this drag face tool, and I'll click on that surface, and I'll just extend that by, let's say, 30 feet towards the south, and then perhaps I can edit part of a surface. So again, if I go back to that surface, I'm just going to change this perimeter to the rectangle option, go back to that surface, and I'm just going to take a 10-foot, just zoom into this here, take out a 10-foot by 10-foot section, and I'm going to drag that back 10 foot. And again, I'm going to extend that a little bit. So if I just orbit around a bit, choose the drag face tool, and just drag that out by another 10 feet. So we've only used literally a couple of the geometry tools there, but you can see already that we've been able to make quite a lot of changes and create quite a neat little covered entrance area there. Switch that back to our standard view. Okay. So let's assume now that our external geometry is complete. I'm going to start partitioning the building into thermal zones. So to do that, if I go to my this block here, the ground floor block, and I can use this partition tool that we have here. So I pick up a snap point at this point, draw, and I can draw a partition any shape that I want to. I'll just put a kink in that one, and again another snap point here. So if I orbit around here, you can see now that I've separated that single zone into 3 separate zones by enclosing this area with partitions. Again, as the model evolves, as the project evolves, the internal layout is highly likely to change. It's not a problem. You can add new partitions, delete partitions, move them, edit them. So here I'm just going to move a section of this this partition. I just orbit around slightly here and pick that section up there and just drop that into there, and then I'm going to delete that part that I don't need anymore. Okay, so we can do that at any stage during the project. So this central zone, which is zone 1 here, that's a kind of in the core area of my building. I'm just going to call that my reception zone. Okay, so let's assume we're done with geometric kind of actions, and we'll now move on to take a look at how you can use DesignBuilder's high productivity data management mechanisms to minimize your data input time. So I'll go to the top, or the site level in my model, and this site level is basically where all of the data that's common to all buildings on our site, things like ground conditions, weather conditions, etc. This is where we specify all of that data, and also where we specify the location. I've set this already as New York City Central Park as the location, as an ASHRAE 90.1 model. And that will automatically load the closest weather file automatically, and it just happens to be Central Park weather file. And it also sets the winter design weather data and the summer design weather data. All of this can of course change, but it comes from the ASHRAE location data set. Just before I move on, I'm going to switch this to multiple design months so that I can run my summer cooling design for multiple months. So having done that, I'll go back to building level. So this is where we can now start to specify the data for this particular building. There could be a number of buildings on the site. So in DesignBuilder, there is, most people use a fairly typical workflow where they create their geometry first and then they input the data using these tabs. So it's a nice, simple, logical progression from left to right along these data input tabs, and that's the process that I'll use today. Each of these main tabs includes a top-level template, like the one you can see here, and that's relevant to the building type and the location. And this template sets most of the default data in the tab that you can see below it. But all of this is editable, so I could change any of these values or schedules, etc. This one is an ASHRAE 90.1 model. So it uses ASHRAE 90.1 data, and also things like 90.1 and 62.1 schedules, heating and cooling set points, and also equipment gains data. Okay, so taking a step back to a conceptual level, DesignBuilder uses what we call a data hierarchy and data inheritance mechanism to speed up the modeling process. So if I take a look here at the navigation panel on the left hand side, the most common data set is at building level. So we set the most common data at this top building level, and that data then flows from the building all the way down into the relevant blocks and zones in the model below. And then I can go and change it at those levels below, but only where you need to change it. So for example, if this was a 100 zone office, then I would set this office activity at the building level, and then I might only have 10 or 20 non-office zones, such as WCs, corridors, kitchens, etc., and I just go to those zones and change the template. So that means for this model, for example, I only need to go to my reception zone and change the activity type for that zone, because all of the other zones are offices. So if I take a look at this, you can see here that the all of the various ASHRAE templates for educational facilities, hotels, etc., are all included within DesignBuilder's library, and there are also lots of other template options available from reputable sources such as CIBSE in the UK. So I'm going to go now back here, and I'm in the reception zone. I can see that there, and I'm going to change my activity for this zone to reception, and that will then change relevant data in the tab below. So you can see, for example, that it's changed the lighting category to lobby. And where relevant, it will also change set points, power densities, etc. This same template principle applies to constructions, openings, lighting, HVAC, all of the model data tabs, where you set the most common data with the template at the building level and perhaps block levels. So templates work side by side with the data hierarchy, and you only need to set the data where it's different at those lower levels in blocks, zones, surfaces. This significantly reduces your data input time. You can literally set up early stage model data in a couple of minutes using these templates from DesignBuilder's library, or using templates that you've created yourself. Also, less data input reduces the risk of input mistakes. So your DesignBuilder models typically contain fewer errors to correct during QA, and that can save an awful lot of time diagnosing any unexpected results. Okay, so going back to building level, let's take a quick look at the construction tab, and this is where we define the opaque building fabric. Again, we use a template from the DesignBuilder library or one that you've created, and these templates will set the data for all of our walls and floors and roofs and ceilings, etc., that you can see below. And the main template or the individual wall templates, etc., can all be changed at block zone or surface level. The template contains all construction and materials data from DesignBuilder's library. And I just want to point out, if you look at this, these options, the data here, if I choose a different template here, let's choose a best practice medium weight template from the library, you'll see that just loading that template has set all of the constructions that relate to that building automatically. You can create, you can change the inputs, you can create as many different templates as you need and set them at any level from the building down to the individual block zones and surfaces. DesignBuilder automatically and intelligently identifies standard adjacency conditions. So appropriate constructions are automatically assigned to external walls, floors, and internal partitions, floors, etc. I'm just going to show you this graphically. I'm going to copy this this ground floor here and just take a copy of that and drop it so that it actually sits below ground level. And you can see straight away, because it's below ground level, DesignBuilder recognizes that. It's removed the windows. It has, if I go to one of the zones in that building, you can see that there's this symbol here, adjacent to ground. The walls all now have ground adjacency symbols. And if I navigate to one of those wall surfaces, you can see that DesignBuilder has also changed the construction automatically to below grade wall. So all of this intelligent automation in DesignBuilder actually saves a huge amount of time. I'm just going to delete that block. I only really wanted to show you that as a simple point. Okay, so I'm going now to move on to the openings tab, and that's where we define our glazing properties. And templates are used in the same way that I've shown previously. So in this tab, I'm just going to focus on some specific glazing and shading inputs. And I'll start again just by loading a best practice template at building level. In our glazing templates, you have the full International Glazing Database library panes available to select, and you'll find those preloaded in DesignBuilder's library. The facades options that you can see here are used to make bulk changes really quickly at early design stages, or if you have a building where a common window to wall ratio percentage is used. So you can see that the default window to wall ratio here is 40%, and that's why the new blocks I drew already contain glazing. I can set different glazing types or different percentages at any level in the model. So if I go here, for example, to the ground floor, I can set the window to wall ratio percentage for all of the windows in that block, and I'm going to change this to a really high value, something crazy like 70%. I'm not advocating that as a glazing percentage. I'm only doing that so that I can show you a clear difference between the proposed building and the baseline building when I generate that a little later. I could equally have set that at an individual surface or zone level. Within DesignBuilder, you can also draw openings onto surfaces and copy them onto other parts of the building. So here, for example, if I just navigate around to this east facade here, I'm just going to go to that surface, and I'm going to just add a let's just add some glazing onto that surface, and then we can copy that window, clone that, and I'll just drop that over on this side. And if I then go to my building level, I can actually clone any of the glazing in my model, or copy it, any of this glazing. So here, for example, I can copy this and drop it onto any of the other surfaces. So here I can just place it onto this roof surface here as roof lights. Okay. There are lots of quick ways to model shading in DesignBuilder, including blinds, overhangs, louvers, or to model adjacent buildings, vegetation. I'm just going to show you a quick tool, really useful tool, this load data from template tool. And this helps us to very quickly set up lots of different types of model data. So I can choose this glazing option and select one of my glazing templates from our library. So if I go here and I'm going to choose let's say a 1 meter overhang with double glazing, and I'll set that, and now I'll go to this target tab here. Now, instead of targeting this by selecting a particular block or zone, or perhaps even selecting a particular wall or opening, I'm going to use this selection filter tool here. And in this case, I'm going to apply that glazing with its shading device onto any surface, or onto the glazing of any surface that has an orientation, let's say 30 degrees either side of south. So that's from 150 degrees through 210 degrees. Okay, so if I click on that and just make sure I've got nothing else selected there, and then click OK, and hopefully you could see that DesignBuilder has just added those overhangs, those 1 meter overhangs, to that south facade. But if I orbit around my model, you can see there are no shading devices applied to any of the other facades. So that's actually a really useful tool to quickly apply different types of data using a variety of different methods. So on to the lighting tab now, and obviously this is used to specify our lighting gains, and again we've got a library of all of the different kind of ashray and other lighting options. I'll leave that one set as it is, but as I've mentioned, we can change. We don't need to stick with the template data, so I can change any of these values. I'll change the lighting power density at building level there to 0.8 watts per square foot, and also I'll switch on lighting control, so linear dimming control, and that will be applied to my whole building. Okay, so let's take a look at HVAC in DesignBuilder. So I open this as an ASHRAE 90.1 model, and when I do that, it means that automatically detailed HVAC will be selected, and you can see that's the icon that you can see here. For more general or early stage modeling, you would perhaps normally start with quick and simple default options for HVAC and natural ventilation, and then you would just add accuracy and detail to the model as the project evolves. For early stage modeling using simple HVAC, you only need to set the relevant template in this HVAC tab and change the inputs like system, fuel type and efficiency. It's really quick and easy to do. So if I take a look at the list of HVAC templates in DesignBuilder, you've got all of the normal systems that you might expect to model. So air to water heat pumps, constant volume, chilled ceilings, chilled beams, various types of fan coil unit, ground source heat pumps, heated radiant surfaces, PTACs, PTHPs, radiators with boilers, unitary systems, loads of different VAV types and a couple of different VRF options. VRF actually probably is a good option for this building. It's relatively small to medium size. So if I select this VRF template, and I'm just going to set that, and then that will set the relevant options in my simple HVAC, or it would do. I'm using detailed HVAC here. Okay, if you need to, even though you've set the template, you can still switch on or off mechanical ventilation, heating, cooling. So you can tailor your system to reflect your actual building systems. And this simple HVAC mechanism is great for early stage, but you can't use it for detailed design or for ASHRAE 90.1 compliance modeling. For that stuff, you need EnergyPlus detailed HVAC, and we'll move on to that shortly. Like simple HVAC, scheduled natural ventilation modeling can be used for fast early stage work, and we can switch that on here. Or alternatively, we can select the EnergyPlus airflow network, and that's available for detailed modeling stages and for lead compliance. Natural ventilation modeling with the EnergyPlus airflow network is much faster and easier in DesignBuilder. So if you've ever been put off using the EnergyPlus airflow network, you really should try it in DesignBuilder. You might well be pleasantly surprised. You can also model mixed mode buildings in both scheduled and calculated NatVent. I'm just going to switch off natural ventilation because this is a fully serviced building. The generation tab here is where we set up our on-site electricity generation systems, PV panels, wind turbines, etc. And the economics tab is where we can specify tariffs, constructions, life cycle cost inputs, etc. I'm going to switch on the tariff analysis, and that will provide both energy and cost savings in the ASHRAE 90.1 proposed versus the baseline results that I show shortly. So moving swiftly on now to detailed HVAC modeling. Okay, we can use templates in DesignBuilder, or we can build the system, or you can build the system yourself and connect individual components together. Here's a list of the templates, and these actually mirror the templates that you saw a minute ago. So you've got all the different types of heat pumps, boiler chiller systems, fan coils, etc. There's some quite funky systems that have been set up in here. So if we take a look at this ground source heat pump system, so this is a radiant system with heated floors and chilled beams. You can see there's an awful lot going on there. So there's some really, really good energy efficient radiant systems, etc., that you can choose in amongst these templates. As mentioned, I'm going to set this up as VRF with heat recovery and DOAS. So I'm going to select that as my detailed HVAC system for this particular building, and I'll use that as my primary 90.1 system. And I can choose which zones. I'm going to load that centralized system into every zone except the reception, because in the reception I'm going to add another component. So I click on finish, and there's my here's my DOAS unit with the heat recovery device, and we've got our VRF outdoor unit, and that serves our VRF indoor unit. And there are indoor units in all of the zones in the building except for my reception zone. Okay, if I want to edit any of these components, I can. So if I go to the VRF outdoor unit, I can edit that, or any of the other components. All of the EnergyPlus inputs that you need are all here, easily accessible. So if I take a look at, let's say, the cooling input options, VRF looks quite simple, but actually is quite a complicated bit of kit for anybody that's ever looked inside one. So there are an awful lot of curves that you need to model for a VRF system. Here is an example of a couple of the curves that have already been created and loaded by DesignBuilder. You can create these curves yourself. There is a tool available, freely downloadable tool from DesignBuilder's website that helps you to create these curves from manufacturer's data. And from this edit dialog, and from all the HVAC dialogues, if we don't understand or we want more information on a particular input, we can click on this help option, and that takes us to the DesignBuilder help specific to that area of the model that we're looking at. Okay, so I'm going to cancel out of that. And I'm now going to show you how we set up a simple DX zone-based system that only operates in selected zones, such as you might find in a reception zone or an office occupied outside normal working hours. I've spoken to a lot of people that don't use DesignBuilder, and quite often their software can't model common systems like radiant surfaces and DOAS, and also there may be a lack of flexibility, such as not being able to easily add single zone systems in a zone that's served by central plant, and they can require quite time-consuming workarounds. So let's take a look at how you could do that stuff in DesignBuilder. We use the concept of zone groups, so that all zones that are contained that use the same system can be grouped together, and this really simplifies the HVAC schematic. So I'm just going to copy that zone group and edit it, because this this configuration will be slightly different. Okay, so I'm now going to connect my VRF system and my air loop to this this VRF unit that's already in this zone. So if I go to my air loop and I go to the demand side of my air loop here, and I can just click here and connect that, flow to flow, and return to return. So that's my system connected, or my zone connected into my air loop. And if I go to my VRF system, then I can connect my VRF unit into the main VRF system. So that centralized system is still serving my reception zone. And what I now need to do is to go to this new zone group and assign the reception zone to that zone group, which is all good. And if I go to my reception zone itself, I've now got all of these options that you can see here on the right, things like convectors and PTACs and chilled ceilings, etc., that I could add to this zone. In this case, I'm just going to add a simple DX unit. So let's add a PTAC unit here, and I'll just select that and drop it into my zone. Okay, and if I go back to my HVAC system now, you can see that that zone is subtly different to the other group, and this PTAC that I've added will follow the system priority that was defined for the HVAC zone group, the original HVAC zone group, and that will automatically then only operate when the VRF system is off. So it's a really good way of adding a simple system to one of those zones that's occupied outside of normal working hours, but still needs to be conditioned. So before I run any simulations, I'm just going to do quickly talk about some QA checking that you can do in DesignBuilder. So if I go back to my building level, take a look at this grid edit tool here, and I'm going just to select a couple of activity related options, and I'll choose those to view and to edit. So I can use this tool for QA checking and for editing. So straight away you can see I changed my activity template in the reception zone, so that data is in red and all of its associated data is in red. So you can very quickly see, using this tool, not only the inputs and the values and the schedules for each zone, but also where you've made any changes, they'll show up in red. We can also use this tool to very quickly make bulk changes to the model data. So if I wanted to change the cooling set point temperature, for example, if I select all of the zones here except for the reception zone, and I want to bulk edit that data, I can select this option, and let's just change my my cooling set point temperature, let's say 79, and that changes it in all of those zones, and then I can apply that data. So it's a really fast way of adding data to lots of zones all in one go. So that's the QA grid edit tool, QA checking tool. Okay, still on the theme of QA checking, if I go to my Visualize tab, I can see here model data, and that shows me color rendered views. That helps me to visualize the construction and glazing assignments. You can set different colors as required for different types of constructions and different glazing types. We've also got this rendered view here. So if I perhaps switch on shadows and switch on the sunpath diagram, this is a really good way of changing the solar position and checking things like glare and overshadowing. Okay, so back to my model. Okay, so let's assume that we've done our QA checking there. After checking the model data inputs, I would normally run test simulations, winter and summer design conditions, and also perhaps during swing seasons. And it's really important to do that for project work, to check that the model is operating as you expect it should. I'm going to skip that for the purposes of this webinar. And I'm just going to now move on to review some of DesignBuilder's calculation and simulation options. And I'll just start with the load calculation, so with the heating design calculation. and I'll just run that using default 1.25 design margin, so default ASHRAE sizing and data. And straight away you can see we've got a graphical heat balance image that shows us where all of our gains and losses are occurring, and also gives us that information numerically in the table below. And if I go to this summary data here, you have a grid that shows you all of the individual calculated values, like the steady state heat loss, and then the design capacity, which is the loss, plus your design margin. Cooling design is very similar. So again, if I go to update the data, what I'm going to do is I'm going to run this cooling design from June through September, again using default ASHRAE settings, and that will enable me to make sure that I capture the peak cooling month through that period. This is a dynamic calculation, so it's run over a 24-hour period for the design day for each of those months. Provides really useful graphical data that helps you also see what's going on with your model. So this heat balance graph here, for example, and we can display that data either for an individual month, or we can just ask DesignBuilder to select the peak month, which I'll do, and you can see that that's actually July in this particular case. Again, we've got a summary tab here, and that shows us all of our peak design flow rates, design capacities, etc. for the zones, and also the totals. And we can export that data to Excel or other spreadsheet tools. So I'm going to move now on to our ASHRAE 90.1 baseline generation. So I can do that really quickly. If I go back to my proposed building here, and I go to my baseline generation icon, and then I get this to my building level and baseline generation. I get this wizard, and that includes all of the key inputs for you to check before you create your baseline building, things like your location, climate zone, floor print, etc. I'm just going to rattle through this. We've got window to wall ratios and the target window to wall ratio to meet the 90.1 requirements, and finish. And that will now create the baseline building according to the ASHRAE rule set, and it will position that adjacent to my actual building. So if I change this to axonometric view, I'm just going to zoom in here, and you should see quite clearly that the shading devices we had in our original building have been removed to meet ASHRAE requirements. The window to wall ratios are, so the glazing, there's less glazing in the baseline building. If I go to my construction tab, you can see the best practice template's been replaced with climate zone 4 data, and as has the data in my openings tab. So all of the building data has been configured automatically. And if I now go to my baseline HVAC system, okay, again, we get a wizard and with our kind of data to check, and DesignBuilder selected system number 3 for this particular building. I could, if I want to, change that, but I'll leave that. I think that's correct, and I can apply that to any zone or all zones in this building, and click on finish, and it's created all of those baseline systems, and they've all been set up in accordance with 90.1. but obviously you should check all of these details before simulating. I'm not going to review the details just to save a bit of time. So I can now go to my proposed building and I can run my comparative simulations for ASHRAE 90.1. So go to the simulation tab and to the ASHRAE 90.1 tab and update the data there. The calculation options have all been configured to meet the 90.1 requirements, and you may have noticed there that I've just reduced the simulation, the number of time steps per hour to 2. I've only done that to speed up the simulation for this particular webinar, but EnergyPlus normally recommends 6 time steps for detailed HVAC simulations. So now we can see our proposed building with a breakdown of its results. I can go now to my baseline building and do exactly the same. So I'll just reduce the number of time steps to 2 and run that calculation for my baseline. This time we're going to simulate the different orientations where required for the to meet 90.1 requirements, and that's actually run really quickly. And you can see that you've got here the comparison between the proposed and the baseline, and the numbers, the summary numbers up the top here with indicative savings. So this is the energy use savings, but we can also look at our cost comparison. So you can see the cost comparison as well. Okay, so that's the ASHRAE 90.1 type stuff, and the last step in that whole process is just to generate a lead V4 submission spreadsheet. So I'm going to call that my spreadsheet 3, and I'm just going to save that. So this there's an awful lot of data to populate in the spreadsheet, so that might take a minute or two. Whilst it's doing that, I'm going to go back to my slides, and let's take a quick look at daylighting and CFD. So DesignBuilder has fully integrated daylighting analysis. You can do radiance, so you can use radiance as the engine to run illuminance and climate-based daylighting options, and you've got all of the options you'd expect: SDA, ASC, UDI, etc. You can also generate reports to gain daylighting credits for LEED V4, options 1 and 2, Green Star, BREEAM. We've also got fully integrated CFD, and its DesignBuilder CFD engine uses the existing DesignBuilder model, and it sets up the CFD simulations in a fraction of the time using that model. You can do isothermal external analysis, so that includes wind speed and pressure, and also temperature, velocity and pressure for internal comfort, age of air analysis, etc. DesignBuilder CFD is suitable for most building related CFD modeling most of the time. So it's a really useful and very cost effective addition to your modeling toolkit. As well as being much quicker to use, another big advantage is the learning time, and the software cost is massively lower than more hardcore CFD tools. Okay, so you can import EnergyPlus simulation results at selected time step to generate CFD boundary conditions, such as surface temperatures, airflow temperatures and rates through specific openings, as you can see here. You can also, there are a lot of tools that enable you to customize EnergyPlus simulations. I'll just actually show this spreadsheet now. It's now I've got the opportunity, so I'm just going to open that automatically in DesignBuilder. And so if I take a look at a couple of the builds, so you can see that we've got here things like the conditioned floor area, the units that we're using, the location and climate zone and all of that good stuff. Lots of all of the data. Basically, this is the USGBC spreadsheet that we've just populated automatically. So I'm sure those that need to use it are familiar with it, and you can see that it's populated things like the data, glazing data for the baseline and the proposed building. And also, if I go to the end, you can see a summary here of the performance data for all of the various aspects of your model. So that's the spreadsheet. Back onto the scripting tools. The next few slides, I just want to give you some kind of wider capabilities. Customizing simulations, mainly using more advanced modeling techniques like scripting. You can customize EnergyPlus simulations by editing IDF data, but a more powerful way of doing that is using DesignBuilder's enhanced EMS scripting to override simulation behavior at runtime. Examples might include adding manufacturer control logic to HVAC equipment, simulating custom shading controls to model advanced facade systems like sage glass, multi-state electrochromic glazing, and maybe also generating custom outputs not normally provided by EnergyPlus. And DesignBuilder's Python and C# scripting tools can modify input data or post-process results for custom reporting. So I'm going to move back now to DesignBuilder, and we've taken a quick look at the spreadsheet, and we've just talked a little bit about daylighting, but I'm going to finish very briefly just now by going back to our proposed building here and running a very quick daylighting simulation and a CFD simulation. So DesignBuilder includes all of the default data that Radiance needs to run its daylighting simulation, so glazing, light and solar transmission, surface reflectances, etc. So unless you need to change any of that data, you're pretty much ready to run your daylighting simulation. DesignBuilder can now produce LEED v4 option 1 and 2 credit reports. Option 1 is an annual climate-based simulation using SDA and ASC, and option 2 is a simpler illuminance-based method. Radiance simulations are now run in parallel, and that significantly reduces the wait times for larger models. In a medium-sized model like this, daylight illuminance results are now ready really quickly, even with quite high-quality settings. So I'm going to go to one of the block levels here. In fact, let me just. I'm going to go to block 2, and I'm going to go to my daylighting tab. So I'm just going to run a daylighting simulation for that block, and I'll set this up as just a standard so it can quickly run that simulation, and I'll do that at default simulation settings, and that'll run quite quickly using the illuminance method. We've also got the annual daylighting option that you can see here, and we can use that to run our climate-based daylighting models. So this is fairly rough and ready. I used a fairly low level of accuracy just for speed in the webinar, but you can see that I've not had to do anything else. I've taken the model that we've set up for the EnergyPlus simulation, and straight away I've run daylighting. All of these numbers you can see here, that's grid data that shows the illuminance level in each cell, and all of the kind of visuals, these can be edited and changed to meet your particular requirements. So that's very quickly daylighting. And lastly, let's just take a look at CFD. So if I click on the CFD option here, again, I'm going to use exactly the same model. And I'm going to update the CFD calculation and basically just start that to run. So as with the daylighting simulation, because we've already built the model, all the geometry that you need really is already there. With CFD, you may need to, depends on what you're simulating, but you may need to add things like supply air diffusers, extract grills, and the airflow data associated with those. And you may also want to include data like your airflow, natural ventilation rates through openings, etc. I'm only really running this simple CFD calculation in this single zone just to reinforce the point that DesignBuilder's interface is fully integrated with the CFD engine, as well as with the EnergyPlus and the Radiance engines that we've just seen in action. Okay, I'm just going to pause the simulation there and close that. Obviously that hasn't completed, but let's just take a quick look. But you can see already that you've started to get some airflow vectors and a temperature gradient in that particular zone. So hopefully you've been able to see that you can run all these different types of simulation from one base model, and that makes the whole process much more seamless. Hopefully by now you've got a feel for how easy it is to create and edit geometry in DesignBuilder, and that's really whether or not you import it or you build it using our tools. You should also have a sense of how much more joined up and intuitive the workflow and the whole modeling process is in DesignBuilder. So I hope this presentation has shown you how the intelligence built into the software could save you an awful lot of time and make your modeling much more enjoyable and less stressful. And why you don't need different simulation tools for early and detailed modeling stages.